So today we are going to look at simultaneous equation, but basically we are looking at tricky simultaneous equations. So if you are new to this channel, please consider subscribing, share, and like the video. Okay. So without wasting time, let's get into it. So the first question, of course, as you can see from the questions, it says 3y equals to 5 minus 2x and y square equals to xy plus 5. So when you look at this problem, you want to solve this question. Okay. Most often when we solve simultaneous equation, we can either use some elimination method or substitution method. So for tricky questions like this, elimination method does not apply here, does not work. So use substitution method. So look at the two equations, which one is simpler than the other. Okay, so this is equation 1 and this is equation 2. So between the two equations, if you look at this equation has one of the variables that has a power of 2. Okay, so I'll consider this one to be simpler than this. So for that, from equation 1, let's make one of the variables the subject of the relation, and we can use that variable and substitute it into equation 2. Then we'll get the other variable that we didn't make the subject. Okay, so let's say from equation 1, equation 1 says 3y equals to 5 minus 2x. Okay, so if we want to make y the subject here, we are going to divide both sides by 3. But I want us to make x the subject. So if I take x here, this is going to be 2x equals to 5, and this one minus 3y. So if I divide both sides by 2, this by 2, this and this goes. So x is equals to 5 minus 3y all divided by 2. So I'll name this equation as equation 3. Okay? So the next thing we have to do, substitute equation 3 into equation 2. So it says substitute equation 3 into equation 2. So equation 3 says, so wherever we see x, we are going to put this x, okay, in equation 2. So equation 2 says y square equals to, so instead of x, we are writing 5 minus 3y all divided by 2. Okay, this is just x times y plus 5. Okay, so from this, the next thing you have to do, this gives you y square equals to, if you multiply this, you have 5y minus 3y square divided by 2 plus 5. Now you want to take these two off here. So for us to do that, we multiply throughout by 2. So you multiply this by 2, multiply this by 2, multiply this by 2. So we have 2 times y square, and this again we are multiplying by 2, and this again multiply by 2. So what happens here, if you multiply by 2 here, that's 2 cancel this. Okay, so that's exactly what happens. So we have 2y square here equals to 5y minus 3y square plus 10. Okay, so now we bring, so if we transpose this one or bring them here, this becomes 2y square plus 3y squared, and this is minus 5y, and this is minus 10. Everything here equals to 0 because we transposed everything here. So this other side of the equation is now 0. Okay, so the next thing we have to do, we add. This gives you 5y squared minus 5y minus 10 equals to 0. So now, if we look at it, there's something that is common, which is 5. So we divide throughout by 5, this by 5, this by 5, and then again by 5. So this cancel, gives you y squared minus y minus 2 equals to 0. Now, from simultaneous equation to a quadratic equation, and of course, we can solve this one easily using factorization method or any of the methods. If you don't know how to solve factorization method, look at my videos as well. We've dealt with factorization, solving quadratic equation using factorization method, formula method, and complete square method. Okay? So when we look at this, we are going to look for two numbers. That's when we multiply them, we have -2. If we add or subtract them, we are going to have -1. And the two numbers will be -2 and +1. So we have y square minus 2y, okay? And we are going to have plus y minus 2 equals to 0. So minus 2y plus y will give you minus y. And if you multiply this, you are going to have minus 2y squared. Okay? So now we have 4 terms. We group them into 2. So this and this, then this and this. So what's common here is y into y minus 2 plus what is common here is 1 into y minus 2 equals to 0. Okay? So now, if we factor what is common here, is y minus 2 that is common. Take it out, open bracket, what remains here is y, and here plus 1 equals to 0. So we've solved them now, because we are solving, so we say y minus 2 equals to 0. So y is equals to 0 plus 2. So we have y equals to 2, or we have y plus 1 equals to 0, y equals to 0 minus 1, so y equals to -1. So in a case like this, we are going to have two answers for one variable, okay, and two answers for the other variable. So now that we have this, we are going to substitute y into equation 3. Remember equation 3 because I want to substitute y into the equation that will give us x, okay? So now that's equation 3. So equation 3 says x equals to half into 5 minus 3y. Okay? So when y is 2, x is going to be half into 5 minus 3 into 2. Okay? Close bracket. So this will give you x equals to half into 5 minus, this will be -1 here. Okay? So remember, this and this is 6. 5 minus 1 is 6. So now if I multiply this, x is going to be minus half. Or when y is equals to -1, substitute again this. So your x is going to be half. So let me bring it here. Okay. So when y is equals to -1, your x is going to be half into 5 minus 3 into -1. Close bracket. So x is going to be half into 5, and this is going to be plus 3. Okay. So you have x equals to half into 8. So if you divide, we have 4. So therefore, when x is equals to half, when x equals to minus half, your y was, so which value did you substitute? That gives you minus half for y. That was 2. So we have 2. Or when x is equals to 4, your y is -1. So those are your answers, okay, for this type of problem. Fine. So let's look at the next problem. Okay, so let's look at the next problem. It says 2x plus y equals to 1, x squared plus y squared equals to 1. Whenever you see short problems, you don't need to panic. Just look at between the two equations, which one is simpler than the other. So when we look at this, the one that is linear, because this is not linear, okay, it has the power of 2. The one that is linear is equation 1. So from equation 1, let's look at equation 1 and make one of the variables, either x or y, the subject, and use that equation to substitute that equation into equation 2, okay, for us to get one of the variables. So from this, the same method, say from equation 1, so equation 1 says 2x plus y equals to 1. Let's make y the subject in this case. So y is going to be y minus 2x. So let's get this one as equation 3. So now we are going to substitute this equation into equation 2. Okay? So substitute equation 3 into equation 2. Okay, so equation 3 into equation 2, wherever we see y in equation 2, we are going to substitute this one. So we have x squared plus, so instead of y, we open bracket 1 minus 2x all square equals to 1. Okay, so now we just need to expand this. So this gives you x squared plus. So if we expand this, we are going to have, but let's do it. So this one tells you it's like 1 minus 2x, 1 minus 2x equals to 1. Okay? Because are giving me issues. So we have x squared plus, now we multiply, we take one of these, we open brackets, 1 minus 2x, minus 2 again, we open minus 2x, we open brackets again, 1 minus 2x equals to 1. Okay? So then, let me try blue. So this gives you x squared. Okay, so multiply this plus 1 minus 2x minus 2x, and that gives you plus 4x squared equals to 1. So this is x squared plus 1, and it gives you minus 4x plus 4x squared equals to 1. So if we add this and this gives you 5x squared plus 1 minus 4x equals to 1. So if we bring this one here, it's going to cancel because we have positive 1 here and this is positive 1. So if we transpose it, it's going to be 1 minus 1. So we are left with 5x squared minus 4x equals to 0. Remember, we cancel this one and this. So now what we have to do here, we factor. X is common. So we are left with 5x here minus 4 equals to 0. So the next thing, this means x is equals to 0, or we have 5x minus 4 equals to 0. So we have 5x equals to 0 plus 4. Okay? So we have 5x equals to 4. We divide both sides by 5. This by 5. This and this goes. So x equals to 4 over 5. So that's just for x. We need y. But remember, we've made one of the equations here. One of the variables, the subject, which gave us equation 3. So substitute x into equation 3. Okay, so remember equation 3 says y equals to 1 minus 2x. So when x is 0, your y is going to be 1 minus 2 into 0, which gives you 1. Okay, and the other one, when x is 4 over 5, your y is going to be 1 minus 2 into 4 over 5. Okay, so that gives you, so I'm coming here, so that gives you y equals to 1 minus 8 over 5. Okay, so find the LCM here. I'll give you 5 minus 8 divided by 5, which gives you minus 3 over 5. So therefore, when x is, so the first value, when x is 0, the y was 1, and when x, so the next value substitute for x was 4 over 5. When x is 4 over 5, the y is minus 3 over 5. So that's the solution to this problem. So just take your time. It's actually tricky, but again, it's very simple for you to solve. Okay? Okay, guys, so let's look at the next problem. This is equation 1, and this is equation 2. So this one says x plus y equals to 4, y equals to x squared plus 3x minus 1. Of course, they're just trying to make things complex, but it's actually very simple. So this one, when you look at this, all you need to do, they're already given here, one of the variables is already a subject of the relation, and that's equation 2. So just use equation 2, substitute that into equation 1, okay, and solve for x, since y is the subject here. So from this, they substitute equation 2 into equation 1. So you have x plus, wherever you see y, you put this one. So that becomes x squared plus 3x minus 1 equals to 4. Okay? So now we correct like term. This and this gives you, so we have x squared this plus this and this, 4x minus 1 equals to 4. The next thing, we bring this one here. So this becomes x squared plus 4x minus 1 minus 4 equals to 0. So we're going to have x squared plus 4x minus 5 equals to 0. So from simultaneous equation to a quadratic equation. The same thing, so we are going to look for two numbers. We use factorization method. Two numbers that you can multiply, that will give you minus 5x squared. When you add or subtract them, you are going to have plus 4x. Okay? And those two numbers will definitely be 5 and 1. Okay? So 5 and 1. If you subtract this, you are going to have 4. If you multiply it, you are going to have 5. So depending now the sign, of course, if you look at this, this is negative, but this is positive. So definitely it's going to be minus here. So it's 5 minus 1, which gives you 4. And if I multiply this, I'm going to have minus 5. Okay? Because 5 times minus 1. So now, since we've identified the numbers, we have x squared plus the first one. So we can put this one as minus x, then plus 5x. So this and this will give you 4x. Then we'll put this one minus 5. So just remember, as I've told you, if you don't know how to factorize quadratic equation, check my YouTube channel. We've done something like this, okay, already. So we have 4 terms. Group them to this. So what is common here is x. We have x remaining minus x into x as 1 plus, we take 5 is common here. We are left with x minus 5 into that gives you 1 equals to 0. So what is common here is x minus 1. We factor it. What is left here is x, and this is plus 5. Everything equals to 0. So if we solve for this, x minus 1 is equals to 0. So x equals to 0 plus 1. So x equals to 1, or x plus 5 equals to 0. So x equals to 0 minus 5. So x is going to be minus 5. So now we just solve for one variable. So substitute x into equation 2. Okay? So equation 2 says y equals to x squared plus 3x minus 1. So when x is 1, so if x is 1, we are going to have y equals to 1 square plus 3 into 1 minus 1. 1 square is 1. 1 minus 1 cancels, so that's 0. So we are left with y equals to 3. Or when x is minus 5, to substitute that, so your y is going to be minus 5 all square plus 3 into minus 5 minus 1. So this gives you y equals to, this is 25 minus 15 minus 1. So minus 15 minus 1 gives you minus 16. Now if you subtract that from 25, you are going to have 9. So therefore, when x is 1, comma, the y equals 3, and when x is minus 5, comma, the y is 9. So that's the solution to this problem. Okay, so just take your time. It's actually very simple. Okay, so we are going to look at one more problem, and the other one you will try that, solve that as an assignment. so I have to solve it again before we look at the other topic. Of course, the other topic we'll be looking at, we are going to look at solving simultaneous equations that involves fractions. Okay, that will be the next topic after this. So when I'll be dealing with that topic, I'll solve the assignment. So when you just check the channel, you will see um, the heading for that topic. Okay, solving simultaneous equations with fractions. So you'll be able to see if you actually got this one correctly. Okay, or maybe you looked at that one before this one. Okay, then just go back and see the way we are going to look at the solution for this, because I'm not going to solve the last one. Okay. Okay. So let's look at the last problem for this video. Then, of course, you have to solve the assignment just like what I've said. Okay. So when you look at this one, is actually very very simple. Okay. As soon as you look at you see this one, you see that one of the variables, which is y here, in both cases, both equation 1 and equation 2, is already the subject of the relation. So all you have to do, if y is equal to this and y again equals to this, all you need to do is equate equation 1 and equation 2. Okay? So equate equation 1 and 2 gives, so equating equation 1 and equation 2 gives, so we have y equals to y. So the first y is 2x squared plus x plus 1 equals to the other y is x squared minus 5x minus 7. So now you transpose everything here. So this becomes 2x squared plus x plus 1 minus x squared plus 5x plus 7. And here we are left with 0. So we collect like terms. This is 2x squared minus x squared plus x plus 5x plus 1 plus 7 equals to 0. So this, subtract this, you have x squared, and this gives you 6x plus 8 equals to 0. So again, from simultaneous equation to a quadratic equation, simply again, we use factorization method. Okay, so when you look at this, you are going to find two numbers that when you multiply them, you are going to have 8x squared. If you add or subtract them, you are going to have 6. Okay, so the two numbers, of course, will be 4 and 2. 4 times 2, you have 8. 4 plus 2, you have 6. Okay, so we have x squared plus 4x plus 2x then plus 8 equals to 0. The reason why we are not writing this again, because when you look at this 4x plus 2x, it's just 6x. So basically, we replace the middle term here with this term. Okay, now so we have 4 terms. So we group them into 2. What is common here is x into x plus 4 plus 2 into what is left here, x. 2 into this is 4 equals to 0. What is common here is x plus 4. Take it out. What remains here is x. And here again, we have 2 equals to 0. So now, we can solve this one. We have x plus 4 equals to 0. So x equals to 0 minus 4, which gives 0 minus 4. Or x plus 2 equals to 0. So x equals to 0 minus 2, which of course gives you minus 2. Okay? So we solve for y. We can use either of these equations. So substitute x into equation 2. I can just use equation 1. So equation 1 says y equals to 2x squared plus x plus 1. So when x is minus 4, so my y is going to be 2 into minus 4 all square plus into minus 4. So this is x plus 1. So this gives you y equals to 2 into minus 4 square is 16. And plus times minus gives you minus 4 plus 1. So y equals to, this is 32 plus 1. This one minus 4. So y equals to 33 minus 4, which gives you 29. Or when x is minus 2, so that means therefore y is equals to 2 into minus 2 all square plus into minus 2. plus 1. Okay? So from that, we have y equals to 2 into 4. Okay? Then minus 2 plus 1. We have y equals to, this is 8 plus this one minus 2. Y equals to 9 minus 2. So y is equals to 7. So therefore, hence when x is minus 4, the y is what? 29. And when x is minus 2, the y is 7. Okay? So this will be the end of this topic. So you try to solve the last problem, and when we shall be looking at solving simultaneous equations with fraction, then I'm going to solve this problem again. So you check if whether you got it correct, or maybe you did some mistake. Okay, so please don't forget to subscribe, share, like, and give the video, of course, a thumbs up, so YouTube will recommend these videos to other viewers out there who may be interested in the same content. Thank you very much for being with me. I'm so grateful.